Hello and welcome back to my channel. Today in this video we are going to discuss Cambridge International AS and A level mathematics. It is pure mathematics 3 paper 3 9709, component is 31 from May-June 2021. So let's start with the question number 1 without delay. Here's the question number 1. Solve the inequality 2 modulus 3x minus 1 is less than modulus x plus 1. So there are several ways to solve it, but whenever we get modulus both the side, the best way is I believe we can square both the sides. So if you square both the side, 2 become 4 and 3x minus this modulus has gone, we can remove this modulus because square will always be a positive number. So 3x minus 1, this is 3x minus 1 whole square now, and the right hand side is x plus 1 whole square. So we open it, we open the bracket, and then we multiply by 4, and we can take everything towards the left hand side. So it is 4 9 is 36 x square, and this x square comes here, it becomes minus x square. Minus 4 into minus 6 is minus 24x, and this 2x came this side, it become minus 2x, and similarly 4 into 1 is 4, and plus 1 came this side, it is minus 1, and this inequality become less than 0. So once it is less than 0, when we know how to solve the quadratic inequalities, we can make it as a standard quadratic equation, quadratic form, that is 35x square, because 36x square minus x square is 35x square. Similarly, minus 26x plus 3 is less than 0. So we know how to solve the quadratic inequality. First of all, we'll solve for the roots of quadratic equation, and for that we can split the middle term. 35 into 3, that is going to be 105. So this 26 can be splitted into parts, 21 and minus 5. So it will become minus 26 and plus 3. So we factorize it. Either we can factorize manually like this, or we can use the formula. We can use a calculator to this, so that we can directly get 5x minus 3 into 7x minus 1. This is less than 0. So from here we can see the roots. If it is equals to 0, the roots would be 1 by 7 and 3 by 5. Of course 1 by 7 is less than 3 by 5, so it would be here, and 3 by 5 would be here. Now it is less than 0. So less than 0 means this part of the curve. So for this part of the curve we have these x values. So these x values would be the values of x. So we can write it as x in between, that is greater than 1 by 7 and less than 3 by 5. We can see from here. So that's the one way. Other way, it can be like, we can take once it is minus and it is plus. So it's best way to take the square and find the quadratic equation, and we can see from the quadratic curve directly from here, because we know the quadratic curve, either it is going to be this cup shape or cap shape, and then we see the inequality. When it is less than 0, we see the below part, below x-axis. I hope it is clear. Let's discuss the second part. And here's the second question. Find the real root of the equation 2e to the power x plus e to the power minus x over 2 plus e to the power x equals 3. We need to find the roots of this equation, and giving your answer correct to 3 decimal places, your working should show clearly that the equation has only one real root. So whenever we have exponents or log, we can first of all simplify this. So we can simply multiply this 2 plus e to the power x to the other side. It would become, here left hand side become 2 to the power e to the power x, 2 into e to the power x plus e to the power minus x, and when we multiply we get 6 plus 3 e to the power x. So we will collect the like terms. We send this whole left hand side to the right hand side. It is 3 e to the power x minus 2 e to the power x, 2, and then minus e to the power x from here, and plus 6. So we got e to the power x minus e to the power minus x plus 6 equals 0. And then we have e to the power x as well as e to the power minus x. So let's take it in the denominator, and we make it as 1 over e to the power x. So we multiply everywhere by e to the power x, or we can say taking that LCM and then simplify the denominator and numerator. we get e to the power 2x minus 1 plus 6 times e to the power x equals 0. I have simply multiplied the whole equation by e to the power x. That's why it is e to the power 2x and it is minus 1 only, because e to the power x would be cancelled, and 6 times e to the power x. So now we can see it can be written as the quadratic equation. It is quadratic equation into e to the power x, because the first one it is e to the power x square, second term we can write it as 6 times e to the power x, and third term is minus 1 equals 0. So since it is quadratic, we can directly solve by using the quadratic formula. That is, here the variable is e to the power x. So e to the power x equals minus b is 6, plus minus b square, that is 6 square. From here we can see, and minus times 4, a is 1, c is minus 1. So we simplify, we get minus 6 plus minus root 40 over 2. So the next thing is e to the power x. We know the e to the power x graph is going to be like this. So where it is used, e to the power x graph will never go below the x-axis. So if it is never going to going below x-axis, it means e to the power x can never be 0. So if it can never be 0, it means e to the power x has to be minus 6 plus root 40 over 2. We cannot take minus, otherwise it would be negative. So we can write e to the power x cannot be negative. That's why only one solution would be there. And what is that solution? We can simplify e to the power x. We can get this from calculator. And since it is e to the power x, we can get x by taking log. So that is ln of the right hand side. And we get it as minus 1.81844 and so on. And since they have asked for the 3 decimal places, so it is only x equals minus 1.818. I hope it is clear. Let's discuss the next one. Here's the third question. Trigonometry. Given that cos x minus 30 degree equals 2 times sin x plus 30 degree, and we need to show that tan x would be 2 minus root 3 over 1 minus 2 root 3. So since here we have sum and difference of like taking the cos of sum and difference of the angle, so we can use the formula. We know cos a minus b is cos a cos b plus sin a sin b, and sin a plus b is sin a cos b cos a sin b. So we are going to use this. Left hand side become cos x cos 30 degree, plus in cos it is, when it is minus it become plus, sin x sin 30 degree. Similarly here 2 times sin a plus b, it is sin x cos 30 plus cos x sin 30. Now we know cos 30 is root 3 by 2, sin 30 is 1 by 2. When we substitute, we get root 3 by 2 cos x plus half sin x equals 2 times root 3 by 2 sin x, because cos 30 is root 3 by 2, and half of cos x. So we can take 2 common and we can cancel these 2, and then we got 1 by 2 common, and we can multiply towards the left hand side. So right hand side, so left hand side becomes root 3 cos x plus sin x equals 2 root 3 sin x plus 2 times cos x. So from here we have sin x and cos x both, and since we need to prove tan x, that's why we have got sin x and cos x. So taking sin x one side, this 2 root 3 will come this side, it become minus 2 root 3. 1 sin x was already there, so taking sin x common, we got 1 minus 2 root 3. From here similarly root 3 cos x will go right hand side, it become minus root 3. So taking cos x become 2 times minus root 2 minus root 3 cos x. So taking the cos x towards the left hand side, cross multiplying, we got tan x equals 2 minus root 3 over 1 minus 2 root 3. And that's what we had to show. Tan x equals 2 minus root 3 over 1 minus 2 root 3. In the B part, hence solve the equation. Whenever it is hence solve the equation, it should come in our mind that we are going to use the previous result. So previously we have seen that cos x minus 30 degree equals 2 sin x plus 30 degree can be written as tan x equals 2 minus root 3. So over 1 minus 2 root 3 of course. So when we need to solve, we need to get one trigonometric ratio. In this case we can get directly tan x, because from the first part, so x is tan inverse of 2 minus root 3 over 1 minus 2 root 3, and from calculator directly we can get it as minus 6.206. need not to solve this and write this value here. It's fine, we can directly use the calculator and we can get minus 6.206. And since we are calculating in the degree, so it should be clear that the mode of the calculator has to be in the degree. So it is minus 6.206, and we need to get the angle between 0 and 360. So for the tan, we know the next angle we always get by adding 180 degree in the previous angle obtained by the calculator. So we add 180 in minus 6.206, we got 173.7939 and so on. And why we got this, because we can see I have used this complete thing as the answer. This value is there in the answer, it is the terminated one. So in the answer we have this whole exact value of tan inverse 2 minus root 3. So we simply add 180 into that, so we got this, and then we add 180 into the next angle, we got this. And we can see these two angles are between 0 and 360. So till one decimal place we will get the solution of it as 173.8 degree and 353.8 degree. That's the solution. Here's the fourth question, A part. Prove that 1 minus cos 2x cos 2 theta over 1 plus cos 2 theta is tan square theta. So whenever we have double angle, we need to choose which formula, which identity we need to use, because cos 2 theta has 3 identity. So it's like basically we can use any of it, but it's fine because we can see it is tan theta. So if we choose wisely and make the numerator as sine square and denominator as cos square, it can easily be obtained. So here cos 2 theta I have used 1 minus 2 sine square theta, 1 minus was already there, and then 1 plus cos 2 theta, the next identity I have used 2 cos square theta minus 1. So when we'll open, we'll get these two cancel and these 1 minus 1 got cancelled. So we got 2 sine square theta upon 2 cos square theta, 2 cancel, and we got tan square theta. That's the easiest way to solve this. Again, hence find the exact value of this. So since it is hence, so we will use the result of first part. In the first part we have seen 1 minus cos 2 theta over 1 plus cos 2 theta is tan square theta. So again, in the integration we don't know the integration of tan square theta, so we are going to use the identity. 3 identities are there. One is cos square theta plus sine square theta is 1, another is 1 plus tan square theta is sec square theta, and then 1 plus cot square theta is cosec square theta. So here tan square theta becomes sec square theta minus 1, and now we have this integration. Sec square theta integration is tan theta, integration of 1 is simply theta, because we are integrating with respect to theta here. So we got this as the integration of this, and then limits are from pi by 6 to pi by 3. So we'll substitute the upper limit first. Tan theta means tan pi by 3 minus theta, that is minus pi by 3, and minus tan lower limit pi by 6 minus tan pi by 6 minus pi by 6. So now we have tan pi by 3. Tan pi by 3 is root 3 because it's 60 degree, minus pi by 3. Tan pi by 6 means tan 30 degree is root 3 by 3, or we can say 1 over root 3 also, but it's fine. I got this from the calculator, and minus pi by 6. So we got two like terms. We'll open it bracket because there is a minus, so it changes the sign. Root 3 minus pi by 3 minus root 3 plus pi by 6. So if we subtract root 3 minus 3 root 3 minus root 3 over 3, we got 2 over 3, 2/3 of root 3, and pi minus pi by 3 and plus pi by 6 is minus pi by 6. So that's the answer. We can write the answer in the decimal also, but in this case they ask specifically that we need to find the exact value, so that's the exact value. Next is question number 5, A part. Solve the equation z square minus 2p iota z minus q equals 0, where p and q are real constants. So we can see it is complex. Next thing is this quadratic. So since it is quadratic, we'll use directly quadratic formula, that is z equals minus b, minus times b is minus 2p iota, plus minus square of b, that is 4p square iota square, minus 4 times a is 1 and c is minus q. and over 2a, that is 2. In this case, since it is quadratic in z, that's why we other constant we will take it as the coefficients. So now we simplify this and we got minus plus 2p iota plus minus iota square is minus 1, that's why it is minus 4p square plus 4q. And now we can see this is 4 everywhere. In the square root we can take out and then this become 2 outside of the square root, and root inside the square root it is q minus p square, and here it is 2p iota over 2 got cancelled, and then we got finally it is p iota plus minus root q square minus p q minus p square. So the two solutions we got as z equals p iota plus root q minus p square and p iota minus root q minus p square. So these are the two solutions. Basically, whenever we write this solution, we should write the new real part first. So we can write it as q minus p square plus p iota, and another solution is minus q minus p square plus again p iota. So it hardly matters. The only thing is the complex number we always remember is x plus iota y, so imaginary part comes later, so that's fine. Otherwise this is the solution. For the b part, in an Argand diagram with origin O, the roots of this equation are represented by the distinct points a and b. Given that a and b lie on imaginary axis, find a relation between p and q. So just to understand, if this is the real axis, this is the imaginary axis, and we know that it is going to be imaginary, it means what? It means there is no real root, there is no real part. If it is no real part, it means since we got the roots as p iota plus minus root q minus p square, so it means there is no real part, it has to be imaginary. It means the value which makes it real as well gives the real part. There should be no real part. It means q minus p square has to be less than 0, because whenever it is greater than 0 it makes it real, because root inside the root, if it is positive, it is going to be real, and once it is real, then it means we cannot get this condition, because it says that a and b lies on the imaginary axis, so it has to be less than 0, which gives the relation between p and q, that is q is less than p square, or we can say p square is greater than q. That's the relation. C part, given instead that triangle OAB is equilateral, express q in terms of p. So I believe there are so many methods. One method I would suggest, which I have used here, is like if we have equilateral triangle, let's say this is the equilateral triangle. So in this case we can take a as anywhere, but I think this is not the proper diagram. In this case we can say that this is the equilateral triangle, in which this is going to be O, and we can take, if it is positive, so we can take it as A here, we can take this point as B. So it is an equilateral triangle. It means if we say OA distance and AB distance, both are same. So I have used the distance formula in this case. It is simply square root of since we are finding this distance OA is just the square, Pythagoras theorem we can use, that is root of the square of the first component and the square of the second component, is equals to, now we are finding the distance of AB. For that we can use root of x1 minus x2 whole square, so we can see it is root of q minus p square, and here it is minus, so we can simply double of this whole square plus p minus p whole square. So when we simplify, this become square and square root got cancelled, these two, and then we got q minus p square here and plus p square. Here it is p minus p is 0, so altogether we got 4 times q minus p square So we have this, and there is a square, so we can take the square both the side. Since there is a square root, we can take the square both the side. We got q from the left side, right side it is 4 times q minus p square. We simplify and we get this. From here, since it is we need to express q in terms of p, so we will transfer p square one side. This p square goes left hand side, become plus 4p square, and q to the right hand side it is 3q square, 3q, and then q equals to 4 by 3 p square. And there is another method, easy method as well, I would say. If we draw this, and we can see that if this angle, it is an equilateral triangle, it means it is pi by 3. So, and the total angle is of course pi, to this become pi by 3, and the remaining 2 has to be pi, half of the left in pi, or you can say. So pi minus pi by 3 is pi minus pi by 3 is 2 pi by 3, and this, it means if you divide into two parts, so it is also pi by 3, this is also pi by 3. So it means if we talk about a point A, then its argument is pi by 3. So if its argument is pi by 3, it means we use the argument formula here. So tan pi by 3, it has to be y by x, and for this it is y is p and x is root of q minus p square. So tan pi by 3 is again root 3 equals p over root q minus p square. Taking the square both the side, we got 3 equals p square upon q minus p square. Cross multiply, we got 3q minus 3p square equals p square. Transferring this to the other side, we got 3q equals 4p square, which gives p as 4 by 3 p square. So that's the another way to do this. We can choose b also. In this case, b, the argument would be 2 pi by 3. So in that case it is going to be 2 pi by 3, and then it is p upon minus of this. Again we will get the same answer. So it's completely on us how we solve these type of questions where it involves the argument also. So that's it for this video. We'll discuss the rest of the question in the next video. Till then, thank you so much.